Your OAuth-protected FastMCP server works perfectly in development, but you know production demands more. Persistent sessions across restarts, encrypted storage, and proper key management. Here's how to configure Redis-backed storage with Fernet encryption for your GitHub OAuth provider, ensuring tokens survive server restarts while staying secure at rest. We'll set up the complete production-ready authentication stack with explicit JWT signing keys and encrypted Redis storage. From key value, AO stores, Redis import Redis store. From key value, AO, wrappers, encryption import Fernet encryption wrapper. From cryptography, Fernet import Fernet. Auth equals GitHub provider. Client ID equals OS. Environ GitHub client ID. Client secret equals OS. Environ GitHub client secret. JWT signing key equals OS. Environ JWT signing key. Client storage equals Fernet encryption wrapper. Key value equals Redis store. Host equals Redis. Example, com, port equals 6379. Fernet equals Fernet. OS, environ storage encryption key. Base URL equals https / your server. Com, hash use https. This demonstrates the secure credential storage pattern combined with OAuth proxy architecture for production-grade authentication. The code shows how to properly externalize sensitive credentials while maintaining encrypted persistence, using a Redis-backed key value store wrapped in cryptographic encryption. What makes this distinctive is the separation between transient runtime secrets and persistent encrypted storage, with explicit key management for JWT signing. The pattern works by layering three concerns. The OAuth provider handles authentication flow, the encryption wrapper secures data at rest, and Redis provides network-accessible persistence. The Fernet encryption ensures tokens are never stored plaintext, while the explicit JWT signing key prevents token invalidation during secret rotation. This creates a clean boundary where the application only handles encrypted blobs, while the storage layer manages encryption-decryption transparently. This approach solves the production challenge of maintaining secure, distributed authentication state. Without it, you'd face either plaintext, token storage, or ephemeral sessions that break on restart. The trade-off is operational complexity. You now need Redis and key management, but the benefit is proper security compliance and multi-instance support. Use this when deploying OAuth-protected services that require horizontal scaling or persistent sessions. Let's break it down line by line. From key value, AO stores, Redis import Redis store. This imports Redis store and a sync-compatible key value store implementation using Redis. It handles persistent session storage for the GitHub OAuth flow, ensuring state survives between authentication steps. From key value, AO, wrappers, encryption import Fernet encryption wrapper. This imports Fernet encryption wrapper, a transparent encryption layer for stored data. It wraps any key value store to automatically encrypt values before storage and decrypt on retrieval, ensuring sensitive OAuth tokens never hit disk unprotected. The pattern follows the decorator wrapper design for clean separation of concerns. From cryptography, Fernet import Fernet. Imports Fernet from the cryptography library, a symmetric encryption implementation for secure data encryption. This provides the cryptographic primitives needed to encrypt and decrypt the Redis storage values, ensuring sensitive client data remains protected at rest. Auth equals GitHub provider. Instantiates the GitHub OAuth provider with secure session management. This is the central authentication handler that processes GitHub's OAuth flow, validates credentials, and manages encrypted user sessions. All subsequent auth operations route through this provider instance. Client ID equals OS. Environ GitHub Client ID. This loads the GitHub OAuth client ID from environment variables, preventing hard-coded secrets in source control. Environment variables keep sensitive credentials secure while allowing different values across development, staging, and production. Client secret equals OS. Environ GitHub client secret. This loads the GitHub OAuth client secret from environment variables, not hard-coded values. Critical security practice that prevents credential leaks in version control and enables different secrets per deployment environment. JWT signing key equals OS. Environ JWT signing key. This sets the JWT signing key from environment variables, ensuring secure token generation for authentication. Environment variables prevent hard-coding secrets, while JWT signing maintains stateless session security between the auth provider and your application. Client storage equals Fernet encryption wrapper. This wraps the Redis store with Fernet encryption, ensuring all client data is encrypted at rest. The pattern combines storage and encryption into a single interface, so the calling code doesn't need to handle encryption separately. Key value equals Redis store, host equals Redis. Example, com, port equals 6379. This instantiates a Redis store for persistent key value storage, using a remote Redis server at Redis. Example, com on port 6379. The store handles session data and OAuth tokens, ensuring they persist across server restarts while remaining accessible to all application instances. This is the backing storage layer that enables distributed session management. Fernet equals Fernet, OS, environ storage encryption key. This initializes Fernet symmetric encryption using the key from environment variables. It ensures all stored OAuth tokens are encrypted at rest, preventing exposure if the Redis store is compromised. The key must be kept secret and rotated periodically for security. This closing parenthesis terminates the Fernet encryption wrapper instantiation, finalizing the encrypted Redis storage configuration for OAuth client data. It ensures all client storage operations pass through both the encryption layer and Redis backend, satisfying security requirements before the GitHub provider initialization completes. Base URL equals https://your server. Com #use https. Sets the base URL for OAuth redirect callbacks. This must use HTTPS in production to prevent interception attacks, as OAuth providers reject insecure endpoints. The URL should point to your server's authentication handler. This closing parenthesis terminates the GitHub provider instantiation, finalizing the OAuth configuration with all required dependencies, authentication credentials, encrypted storage, and server endpoints. Without this, the object remains incomplete, preventing proper OAuth flow initialization. Always verify all required parameters are included before closing the constructor. Production-grade OAuth security. The GitHub provider configuration demonstrates FastMCP's production requirements for token persistence and encryption, where JWT signing key and Fernet encryption wrapper work together to survive restarts while protecting credentials at rest. The encryption wrapper only protects data at rest, not in transit. Always pair it with HTTPS for complete security. This pattern is mandatory for distributed deployments, but adds no complexity to your application code.
The key that locks everything must itself remain unlocked.